problem states that a lawnmower has a mass of 62 kilograms. The net force on the mower is 44.5 newtons. What is the magnitude of the acceleration of the mower? So we're going to be using Newton's second law. And we basically just have to rearrange Newton's second law for the given value that we want. So Newton's second law says that the sum of the forces equals mass times acceleration, and these are vectors. Now the problem only gives us one force, so we don't need to sum up any forces. It only gives us one. And it's interested in the magnitude of the acceleration, so we don't have to worry about the vector hats. So I can rewrite this then as F equals ma. And what are we looking for here? We're looking for acceleration, so I simply divide both sides of the equation by m, and I'm left with a equals F divided by m. So now I can put in my units. So this is equal to, well, let's see. So we have 44.5 newtons, and the mass is 52 kilograms. So I'm going to put in 44.5 divided by 52 into my calculator, and I get a decimal value of 0.86 if I'm rounding to two decimal places, and my units are newtons per kilogram. Now, that might not look like an acceleration. Our acceleration units are meters per second squared, so we have to remember what the units of newtons actually are. So a newton is equal to 1 kilogram accelerated at 1 meter per second squared. And when we put these units into the equation, we can then see that we have kilograms divided by kilograms, and we're left with meters per second squared. So the magnitude of the acceleration is 0.86 meters per second squared. Okay, so that's pretty straightforward. So let's look at this other problem over here. So we're told that a ball is kicked with a force of 28 newtons, and it accelerates at 62.2 meters per second squared. What is its mass? So again, I'm starting with Newton's second law, and I'm only worried about the magnitude here, and we only have one force. We're given one force, so we don't have to worry at this point about summing up the individual forces. So we're looking for mass, so I divide both sides of Newton's second law equation with acceleration, and I'm left with mass is equal to force divided by acceleration. And I plug in my values now, so I have my force is equal to 28 newtons, and my acceleration is 62.2 meters per second squared. Now I need to resolve these units and take care of this division here. So for the division, it is 28 divided by 62.2, and this gets me a decimal value of 0.45 to two decimal places, and I still have newtons divided by meters per second squared, which is a complex fraction. And I'm looking at my units here. I should be left with just kilograms. So I know I have mass, and this should hopefully resolve to kilograms. So we refer back to our definition of newtons, which is a kilogram accelerated at 1 meter per second squared. And I can rewrite this then as 0.45 times kilograms meters per second squared divided by, now I have this other meters per second here, so this goes in the denominator, meters per second squared. And I can now see that I have a meters per second squared in the numerator and a meters per second squared in the denominator. So my mass is then equal to 0.45 kilograms. So that is my answer. So when I work these problems, one of the most important steps to ensure that everything was done correctly and with the algebra and the arithmetic is to actually do the unit analysis and make sure that your final answer has units that make sense. If I'm looking for a mass, well, I'm going to have a kilogram unit. If I'm looking for acceleration, then I know that I need to have meters per second squared. And if there's something that doesn't tell me exactly what those units are, then I need to resolve this. So if I have this unit of newtons here and I'm not quite sure that this resolves to meters per second squared if you divide it by a kilogram, well, then just do the alternate definition of newtons and plug that into the equation so you can be sure that you're getting the appropriate units.